The closer we get to the core of a computer, the more unfamiliar things may appear. In fact, we're getting closer and closer to the atoms of the computer, the ones and zeros. This is the language of the machine, rather than a language we're used to using. At this level, you can still talk to the processor and tell it what to do. An instruction set used in what is called ISA, or Instruction Set Architecture, is code that the computer processor, CPU, can understand. The language is ones and zeros, or machine language. It contains instructions or tasks that control the movement of bits and bytes within the processor. But if it's ones and zeros, how do we actually communicate with the processor? Systems programmers use assembly language, which is a type of programming language. The statements are assembled into machine language, into the instructions that the processor can understand. Assembly language is a lot like machine language with labels, because binary alone would quickly get hard to keep track of. What makes up an instruction set? When we start talking about ones and zeros, machine language, assembly language, and registers, it might all become murky. Let's start with the overall structure of an instruction and go from there. The instruction set consists of a limited set of unique codes that let the processor know what to do next, along with some basic rules of how to express them. We can explain more about it using the following. 1. Instruction length. This can vary. 2. Opcodes, which is the command to be carried out. 3. Operands, which is what the command will operate on. 4. Registers, which include internal locations, which are limited in number and ability, but quick to access. And 5. Memory, which includes external storage and involves a larger and more versatile number of locations, but slower to access. So, what is an instruction? Let's take a look at instructions and instruction length. 1. About an instruction. An instruction can vary in length depending on the architecture. In x86 systems, the length of the instruction is typically 1 to 3 bytes for the opcode, plus a number of bytes needed for the operands, depending on the addressing mode. What's an addressing mode? Different operations may be performed directly on pure numbers, indirectly on numbers in internal registers, or very indirectly on locations in main memory. Each of these is a different addressing mode. Additionally, shorter instructions do not always mean faster instructions. Sometimes, a short instruction hides a lot of machine cycles. Think of riding a bike that's too small for you. You might be pedaling faster, but are you really getting there faster? The instruction itself is made up of a bit pattern, those ones and zeros again. But in assembly, you will see syntax such as MOV, ADD, and CMP. These are called mnemonics rather than opcodes. A mnemonic is something that makes another thing easier to remember. For example, to add 2 operands such as the number 42 to the contents of the EAX register, the code is 2. About instruction length. An instruction is a specific length, as specified by the ISA. However, consider the following instruction, shown in this figure appearing here. The length of an instruction is dependent